All right, got some new sunglasses, so let's talk about graphing using intercepts. So we talked about solutions and plugging in values for x and y to check if a point is a solution to an equation or a function in the last video. And we also made the point that you only need 2 points to graph a function, an equation, a line on a x and y coordinate plane. So we're going to use that to our advantage because we'll use intercepts. If we can find both intercepts, the x-intercept and the y-intercept, we'll be able to graph any linear equation, any linear function. So what are intercepts? Well, we got 2 of them, the x-intercept and the y-intercept. Your x-intercept is the point along the x-axis that intersects with the function, and the y-intercept is the point along the, let's fix that, y-axis that intersects with the function. So what does this look like? Well, it looks like this. Let's say I have a function that maybe it looks like this. Well, right here, I have my x-intercept, and then right over here, I have my y-intercept, right? Because this is the, let's get that white. This is the y-axis, and this is the x-axis, right? So the x-intercept is where the yellow line intersects with the x-axis, and the y-intercept is the point along the y-axis that intersects with that yellow line right there, simply put. And let's make note of something really important. The x-intercept, right, this point right here, maybe its x value is like -1. Well, what's its y value? Well, it's 0 because it's along this x-axis. Every y value along the x-axis is 0. So for your x-intercept, the y value is always going to equal 0. And opposite to that, right, this y-intercept, maybe its y value is like +1 here, but the x value, since it's along the y-axis, is 0. So x, I'll put that over here, x is going to equal 0 always for your y-intercepts. So we're going to use that to our advantage. First example, y minus 3x equals 9. So let's find the x-intercept first. And since we know that the y value of the x-intercept is going to be 0, right, we're just going to plug that into our equation up here and then solve for the other missing variable, which is x. So we will have 0, right? We're plugging that in for y. So 0 minus 3x equals 9. And let's simplify that left side. 0 minus 3x is going to be minus 3x equals 9. We want to isolate x, so divide both sides by -3. Those will cancel, and we get x is equal to -3. All right, so we have x equals -3, y equals 0. So the point on the graph that is our x-intercept is going to be -3, 0. So I'm going to plot that right there. All right, the y-intercept, same thing, just kind of backwards. We know that y-intercepts have a x-coordinate that is 0. So x is equal to 0 here. And then we're going to plug that in for x into the equation. So we'll get y minus 3 times 0 equals 9. This right here, you could do, it's going to be 0, right? -3 times 0 is 0, so we'll have y plus 0. We don't even have to write that, but we'll get y is equal to 9. So combining those two x and y values, the point for the y-intercept is going to be 0 and 9. So that's going to be like up here. Now all we do is connect the dots, and more or less that's what the graph is going to look like. If you plug this into a graphing calculator, this is what you'll get. So you find your intercepts, connect the dots, and you're done. -3x plus 2y equals 6, no different than what we did before. X-intercept, right? That's where y equals 0. So we're going to plug that into the function, into the equation. Negative 3x plus 2 times 0 equals 6. Well, 2 times 0 is 0. So we'll get negative 3x plus 0 equals 6. Negative 3x plus 0 is just negative 3x equals 6. Divide both sides by negative 3. X is equal to negative 2. So the point for our x-intercept is going to be negative 2, 0. And for the y-intercept, right, this is where x is equal to 0. Plug it into the equation, so negative 3 times 0 plus 2y equals 6. Negative 3 times 0 is 0, so I'll just have 2y equals 6. Divide both sides by 2. Y equals 3. The point for our y-intercept is going to be 0, 3. So we'll plot both of those. 0, 3, that's going to be right there. And negative 2, 0 is going to be right here. So we plot our intercepts and then just connect the dots. Last one, negative 9x equals 3y plus 9. So x-intercept, right, that's when y is equal to 0. Plug that into our equation. Negative 9x equals 3 times 0 plus 9. 3 times 0, that's just 0, so we can cancel that out. Negative 9x is equal to 9 is what we have now with the equation. Divide both sides by negative 9 to get x by itself, and we'll get x is equal to negative 1. So our x-intercept is at negative 1, 0. Your y, or our y-intercept, right, that's when x is equal to 0. Plug that into the equation. Negative 9 times 0 is equal to 3y plus 9. That cancels out. Negative 9 times 0 is 0. So we'll have 0 is equal to 3y plus 9. I'm going to write it as 3y plus 9 equals 0. So just swap both those sides, rewrite it that way. We'll subtract 9 from both sides. That will cancel out, and we'll have 3y is equal to negative 9. Divide both sides by 3. The 3's will cancel there, so we'll just be left with y is equal to negative 3. And the point for our y-coordinate is going to be 0, negative 3, which that's going to be down here. And the x-intercept is negative 1, 0 right there. Plot your intercepts and connect the dots, and that's it.